Hello, discussing errors today. Now, what is an error? In common parlance, in common everyday language, an error is like a mistake, something you do wrong. But in physics, that's not quite what it is. In physics, you can actually have an error even when you do not make a mistake. Errors will happen irrespective of the correctness of your procedure. Of course, if your method of doing things is faulty, then that increases the size of the errors. But errors will always be there, even if the experimenter, the physicist, does not make a mistake, does everything right, yet there will be errors. So then, what exactly is an error? Well, an error is an uncertainty in measurement. Now, what is that exactly? Well, it's the difference between the measured value and the true value. Now, an interesting problem arises here as to how do we calculate this difference between the measured value and the true value. For instance, why would you be making a measurement if you knew the true value? The true value can actually never really be known, because you always get some measured value as a result of a measurement process, which will always have an error. And therefore, true value is really never known. And if true value is never known, how do we calculate the difference between the measured value and the true value? Well, it can't be calculated exactly, but there are methods, there are processes for making estimates, and we'll be learning about that in some of the later videos. But as of now, we are going to just focus on the kinds of errors you can possibly make. We'll have a brief classification of errors. Well, there are two kinds of errors, broadly speaking. You have systematic errors and you have random errors. Now let's talk about systematic errors first. Systematic errors are errors which always happen in the same direction. Now, what's direction for an error? I mean, do errors have direction? Yes, kind of. An error can be an overestimate or it can be an underestimate. So there can be two possible directions for an error: an overestimate or an underestimate. An overestimate is when the measured value is greater than the true value, and an underestimate happens when the measured value is less than the true value. Now, a systematic error will absolutely always occur in one direction. So if you're taking lots of readings and all those readings are overestimates, then you have a systematic error taking place. If all the readings are underestimates, you have an error that's systematic in nature. And as the name suggests, systematic error, this seems to indicate as if there is a system flaw, and that's exactly what it is. And once this system flaw is taken away, once you remove this system flaw, the systematic error can be removed completely. Systematic errors have system causes, system level causes, and therefore once you address the system, once you address your process of making the measurement, you take care of the instruments if they have any zero errors, etc. Once you take care of the system flaw, the systematic error goes away completely. With systematic errors, it's always possible to identify their cause, and therefore these errors can be removed completely. Now comes the other category of errors, which are called random errors. Now, random errors are the kind of errors which can happen in both directions. So if you're taking lots of readings of some quantity, and while taking those readings, what we observe is some of those readings are overestimates and some are underestimates. In that case, we are dealing with a random error. It varies randomly in direction as well as magnitude. So a random error can happen in both directions. It can be overestimate in some readings, can be an underestimate in some of the readings that you take. Now, with random errors, it is not possible to identify a cause. They happen, as the name suggests, due to random factors. Random factors are factors beyond your control. Weather changes happening could affect readings of physical experiments. Humidity changes can affect readings in physical experiments and things like that. So factors which are very difficult to identify and control, those lead to what are called random errors. Now, random errors cannot be removed completely from your readings, but these random errors can, however, be reduced quite significantly by taking a large number of readings. Now, to reduce random errors, you take a very large number of readings, as large a number of readings as you possibly can, and then you take their mean and take the mean to be the representative true value. Now, when you do this, when you take a large number of readings and then arrive at a mean, then the overestimates and the underestimates tend to cancel out, and you end up getting fairly close to what should be a real true value. And that's how random errors are reduced. However, these random errors can never be removed completely. Now, one little discussion on two terms that we use very, very frequently in physics. One is accuracy and the other is precision. Now, what is accuracy? What is precision? Accuracy refers to the closeness of the measured value to the true value. Now, if the measured value is closer to the true value, we say we've made an accurate measurement. Now, the other term, which is often confused with accuracy, is precision. Now, precision is the closeness of measurement readings to each other. Now, when will measurement readings be closer to each other? That will happen when the instrument that you use has a smaller least count. Smaller the least count, closer the measurement readings get to each other. And that refers to precision. Now, these two terms are often used kind of interchangeably, but they have very specific meaning in physics, and please remember, whenever we use them, we mean slightly different things. Thanks for watching.